So, in this lecture, we'll discuss today the concept of circular shift and a linear shift that we have discussed. Hello. कुछ नियम है अनुष्का बनर्जी सी वेटिंग रूम all. Okay. Hello. 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 My voice audible?
Yes, sir.
Okay, fine. Thank you. Okay, so this class we want to go further, provided we have okay. So provided you have the idea of previous class circular shift. All of you are very much clear about circular shift?
Yes, sir.
All right. Now, if I see that if you have any doubts in circular shift or everything is clear? Huh? Circular shift.
Yes, sir. ठीक है.
Everything is okay. Acha,
Yes.
as I see, Ananya, Pinakshi, Akash, Amit Nandi, Anushka Banerjee, Oritriya, Keapal, Oniket, Arno Bhattacharya, and one is
Yes.
there. One is Redmi. Who is Redmi? Pinakshi Ghosh. Who is Redmi? One is there. Redmi. Who is he? Apart from the name I have told, Redmi one is there. Who is he?
Response करते हैं.
Ek minute. Let me clarify the name. Who are there in the list?
Yes.
Who are there in the list? I am seeing 11 participants. Right?
Yes.
11 participants. Akash Chatterjee, Amit Nandi, Oritriya, Keapal, Ananya Ghosh, Oniket, Anushka Banerjee, Arno Bhattacharya, Pinakshi Ghosh. Another one is Redmi is there. Who is Redmi? Is showing Redmi. Who is Redmi? Another I couldn't identify this Redmi and Ardhendu Paja Arusri. Right. Only thing actually this Redmi I couldn't identify. Who is Redmi? Redmi I didn't identify.
Response करना ना.
Okay, so actually I will remove them which I didn't understand. Actually, I have gone through the detailed security aspect of Zoom. So it is said that we can only admit those people to whom I can identify. All right. If I cannot identify a people, then I will not allow. All right. Now onwards. So Redmi I didn't allow. The Galaxy 9 also I didn't allow. So only I will admit those people who I understand by name. All right. If we do that, then there will be no risk of data. And as far as this class is concerned, class is having only data of some course. So that course, right? So there is nothing too much worry about. But only thing, as far as the security advisory, it is said that you only allow those people which you know. They will be there as a participant. Unless I admit, nobody can enter into the system, right? So I have to admit everybody, and I have changed all these settings. All right. Another important thing that I want to mention, that regarding team link, I have also worked on that in this week. That team link actually very slow, means actually it is overloaded now. Most of the people are trying to use team link, and 200 means you require a lot of bandwidth. So using my network speed, we cannot continue with your team link. All right. So only those people I will allow, those who I know by name, right? Other than if we show Galaxy, if it is so Redmi, then those people will not be allowed to the class, because this is for security reason, nothing else. This is a security reason from your end. All right, because since I am the host, so security problem may arise my end only. So I have to take care of all these things. I have read that advisory. And after reading all this advisory, I have come into the conclusion that we have to change all the security settings. I have accommodated everything in my Zoom installation, right? So I hope it will all right. But in case of any difficulty, you may still inform me. Okay, let us move. So circular shift, if you have no doubt, then what I can say that we will to move ahead with this conclusion that I said that if n is this, what does it mean? If n is negative, if n is negative means n less than 0. If n less than 0, then n modulo n, that will be n plus capital N. Agreed? And if n is positive, then n capital N, that is called modulo n, that will be small n only. That means whatever argument is there, that plus n. For negative, for positive, it will be that argument only. If you understood this clearly, then only I want to proceed. Shall I proceed or not?
Yes, sir.
Very good. Then I hope you have understood. Now this is based on the previous thing. Now I would like to discuss on property. Previously, what I have discussed, that physically, how a linear shift of a signal looks. If I have a signal, then what does it mean, linear shift? And I have tried to give the example where I have shown you that what essentially circular shift is, right? What essentially circular shift is. Now in this class, once we understood that concept, then we would like to derive the property that if I have a signal xn having DFT x of k, then if I circularly shift that signal by n, then what will be the DFT of that? Xn having DFT xk. The question is, I have to find the DFT of a circularly shifted signal, right? If I write n minus m, this suffix n, which means it is a circularly shifted signal. It says that its DFT will be x of k e power j 2 pi km by n. That you have to prove. Now see, DFT of x of this, DFT of Borun Shatpati, okay. Let me allow him. Okay, n equal to 0 to n minus 1, x of n minus m, n e power j 2 pi kn. Do you agree with that? This step, I hope you are agree with that. Now, try to understand this. Now, n minus m, n, this will be n minus m plus n for n minus m less than 0. And this will be equal to n minus m if n minus m greater than equal to 0. Do you agree with that?
Yes.
Yes, very good. Now tell me. Now I am having this summation n equal to 0 to this, 0 to this, right? This is the equation 1. Once from what I can write, shall I write that 0 to m minus 1, n is equal to m, n minus 1, same thing. Try to understand this, very important here. First thing is, when this will be negative, n minus m, n minus m will be negative when n is 0 to m minus 1. Agreed? I repeat, when suppose n equal to 0, it is minus m, negative. N equal to 1, still negative until it is m minus 1. At m minus 1, it is minus 1. When n equal to m minus 1, what is the value?
Minus 1.
Minus 1, still negative. Now, if it is more than m minus 1, more than m minus 1 means m, then it is 0.
Zero.
Second condition. So what I am writing 0 to m minus 1. This will say that this condition will be accommodated. Agreed? Now,
Yes, sir.
n equal to m to n minus 1, because my summation is 0 to n minus 1. So I have to go 0 to n minus 1. So n equal to 0 to m minus 1. Then next will be starting with m. So if it is m, this becomes 0. And if it is more than that, more than m, up to n minus 1, it is positive. So I will write n minus m. I will write n minus m. Then same thing I have written. Do you agree this step to this step?
Yes, sir.
Yes, sir.
Is understood?
Yes.
Now,
Yes, sir.
the question is why m minus 1? The m minus 1, because until m minus 1, this quantity
Getting negative.
is negative. Once it is negative, then only I can understand how to put this value. I have to clearly identify which is negative or positive. All right. Now,
Yes, sir.
now I am starting with this term. In this term, this is n equal to 0 to m minus 1. This term, first term I am taking. Now I am saying n minus m plus n equal to p. Then when n equal to 0, when n equal to 0, what is the value of p?
N minus m. Capital
N
N
minus m.
minus m.
তাহলে capital n minus m. তাহলে when n equal to 0, p equal to capital N minus m. This is n minus m. Okay. And when it is m minus 1, n equal to m minus 1, if I put here, corresponding p equal to n minus 1.
N minus 1.
Okay. Now I will substitute, here it is n. In place of n, I am writing p minus m plus n. Agreed? Agreed? Now, okay. Now, আচ্ছা এখানে একটা কে মিসিং আছে না, কেটা লিখতে হবে। হ্যাঁ, এই কেটা মিসিং আছে, এখানে কেটা আছে না, এই কেটা এখানে হবে, এই কেটা এখানে হবে। ওকে, আচ্ছা নাও ইউ সি এখানে একটা কে মিসিং আছে। তো ই টু দি পাওয়ার জে 2 পাই পি প্লাস এম মাইনাস এন বাই, এটা বোঝা গেল? দ্যাট সাবস্টিটিউট n equal to how much? p minus m plus m minus n. n equal to p plus m minus n. From this I am finding n. Okay. Acha, here one k will be there because k is still there. This is a mistake. I have to correct it. Okay. Now same thing. I am writing e power j 2 pi. Again here also there will be one k. Now p plus m by n. Now e power j 2 pi minus n by n. This is equal to 1. Agreed? Agreed?
Yes.
So this is equal to p equal to n minus m, n minus 1. This is your thing. Agreed? Acha. Now second term. Second term means this term. I am working with this term. Okay. This term, what is there? This term n equal to m to n minus 1 x of n minus m to power kn by n. All right. Second term. Okay. Now I am writing n minus m equal to again p. So n equal to m, this one. This when n equal to m, what is the value of p? P equal to 0. Fine. So p equal to 0 হয়ে গেল. Now when n equal to n minus 1, when n equal to n minus 1, this will become n minus 1 minus m, n minus 1 minus m. N minus m equal to p লিখবো. Then I will replace n by p plus m, n by p plus m. K is there here, no problem. Okay, so this will be equal to p equal to 0 to n minus 1 minus m, x of p e power minus j 2 pi m plus p k by n. Agreed? Agreed?
Yes.
No doubt, though. Now I am trying to add this term and this term. If I add these two terms, that will be nothing but what? DFT of this. DFT of this is this. This is equal to this plus this. So these two terms I have derived. One is this, another one is this. So if I add these two, DFT will be x of n minus m of n, p equal to 0 to n minus 1 m. That thing. Another term is n minus m to n minus 1. This thing. Do you agree with that? Is it all right?
Yes, sir.
Yes.
হ্যাঁ
Yes, sir.
Fine. Very good. Now, if you look at this term, what is there, and this term, what is there, they are identical. Then I can write p equal to 0 to n minus 1, 0 to n minus 1 minus m, then n minus m to n minus 1. If I add these two, 0 to n minus 1, x of p or j 2 pi m plus p k by n. Do you agree with that?
কি হলো
হবে?
Yes, sir.
আচ্ছা, তারপরে পরের
কি
টার্মটা
আরেকবার বলুন স্যার
আমি বলবো।
হ্যাঁ।
এই দুটো টার্ম ধরো অ্যাড করছি, তাহলে এইটাও যা এটাও তাই। This is same and these two are same. Now this is 0 to n minus 1 minus m. This term is starting next term onward. N minus m to n minus 1. So I can write whole thing 0 to n minus 1. Same thing.
হ্যাঁ
Okay. Now this summation is over p. Therefore I have to take the m out. So what I have done, e power j 2 pi mk by n, then p equal to 0 to n minus 1 x of p to the power j 2 pi k by n. This is nothing but DFT of xp. DFT of xp, endpoint DFT of xp, which is equal to x of k multiplied by this. Therefore, what does it mean? That if x of n having DFT x of k, then x of n minus mn having DFT x of k e power minus j 2 pi km by n. Agreed?
স্যার এইখানে ওই x of n minus m n এর এই নিচের ওই এক্সপ্লেনেশনটা কি বললেন আমি ওখানে শুনতে পাইনি
n minus m mod
ওটা
n.
এই হ্যাঁ ওটার এক্সপ্লেনেশনটা কি বলছেন
ওটা বলে this is circular shift. If it is a circular shift, then I have to write x of n minus m mod n. If it is a linear shift, then it will be simply written x of n minus m.
আচ্ছা
So in circular shift means mod n operation, which I have explained in circular shift previous class. This is the application of that learning. So this is a very important aspect. If you still have any doubt, you can ask. Otherwise, I will go to the next topic on the basis of last two class understanding. This class, the so far, and previous class. On the basis of that, I will go to the next topic, which is called circular convolution, which is very, very important topic. At least you will get 5 to 6 marks in your final exam, whenever it will be. If you have any doubt, you can ask. No doubt? No doubt? Shall I proceed?
yes
স্যার
If you,
ফার্স্ট থেকে রিপিট করে দেবেন
first
আজকে একটু ফার্স্ট থেকে রিপিট করবেন
থেকে
হ্যাঁ হ্যাঁ স্যার একটুখানি আজকে আমি লেট হয়ে গেছিলাম মানে জয়েন হচ্ছিল না কিছুতে মিটিংটা ওর জন্য একটু লেট হয়ে গেছি
ঠিক আছে তুমি আগের ক্লাসটা করেছো তারা গতকালকে
হ্যাঁ স্যার আগের ক্লাস হ্যাঁ
আচ্ছা ঠিক আছে দেখো চট করে দেখো x of n having dft x of k, then x of n minus m, if it is mod n, that is circular shift, then it will be x of k multiplied by e power j2 pi km by n. Right. So what I have said that this having DFT this, then this will be having DFT this. Now what I have to find, this is given, so I have to find the DFT of this. What I am writing, DFT of this. So this is the straightforward formula, n equal to 0 to n minus 1 x of n minus m n e power minus j2 pi kn by n, written. Now I have to apply the concept of modulus. This concept I have explained in last page, that x of n mod n, which means if n is less than 0, negative, then n mod n equal to n plus n. So whatever argument is there, that will be added with this factor. And if n is greater than 0, here it is n greater than 0. So if n greater than 0, n mod n will be the whatever argument that is there. N will not be added. This is the case when n is positive. This is the case when n is negative. That I have derived previous class, and everybody understood this. Those who have attended, they said they have understood. Then we have proceed. Now we want to apply this concept here so that I can break this modulo operation. You have to break this modulo operation means you have to identify positive and negative. And for positive, what is the situation? Negative, what is the situation? That you have to substitute. With that, you can identify this. Now, what I am saying, that if this is n minus m, this is less than 0, that is n minus m plus n. If it is greater than 0, that is n minus m. Then what I am doing, I am breaking this summation 0 to m minus 1 and m to n minus 1. So adding this to summation will give you this equation, which is nothing but DFT of x n minus m mod n. Agreed? Now I am breaking into two sums. So n equal to 0 to m minus 1. N equal to 0 to m minus 1 means if n equal to 0, that is negative. If it is m minus 1, then it is minus 1, still negative. So in this term, only negative terms are there. If n is negative, then this will be replaced by this. So this will be replaced by x of n minus m plus n. And when n equal to m to n minus 1 is positive, it will be replaced by n of n minus m, because n minus m greater than 0. So when n equal to m or more, n equal to m it is 0, it is more than m, like m plus 1, it is 1. So m to n minus 1, this becomes positive, so I will replace x of n minus m e power j2 pi kn by n. Then what I have said, that if I simplify this with assuming that n minus m plus n equal to p, then what is m, when n equal to 0, p equal to this. When n equal to m minus 1, p equal to n minus 1, then if I substitute the limit of n and limit of n, then I will get something like that. Right?
এটা p plus m কেন হলো?
কোনটা?
nটা
এটা?
এই third line না, তারপরের লাইনে,
এখানে? এটা?
তারপরেরটাতে
এটা? কারণ হচ্ছে
last, হ্যাঁ
কারণ e to the power j2 pi n by n, I have said না here
1
শুধু কি এখানে একটা k মিসিং আছে, কেটা তোমরা লিখে নেবে। ওকে, আর তারপরে নেক্সটটা যদি আমরা যখন ভাঙবো, when next we will resolve, then what happen, n minus m equal to p. So n equal to m means p equal to 0. This is p equal to 0. N equal to n minus 1, n minus 1 minus m. So it is n minus 1 minus m. Corresponding this limit, this will be the limit. Right? N minus m equal to p. Then again n will replace by m plus p, that is k by n. Then if I add these two, whatever we have derived, see, we are having two things here. We are having two things here, like two summation here, two summation here. We have derived each summation individually. Once you derive each summation individually, then I am adding this together. If I add this together, ultimately if I add this together, if we look into the term, that this term and this term are same, and this is 0 to n minus 1 minus m, this is n minus m to n minus 1. So it is total actually 0 to n minus 1. So xp to the power j m by k plus 1. Then again, if we see, this will be p to 0 to n minus 1 xp, and m is not there in the summation. Therefore, I am taking m out, e to the power minus j2 pi m k by n. I am taking it out. P is equal to 0 to n minus 1 xp e power j2 pi k by n, which is equal to x of k e to the power j2 pi m k by n. This is DFT of x of n minus m mod n. That means if xn is my signal, x of n minus n mod m, which is circularly shifted signal, of what? X of n. Then Correspondingly, what I see that DFT is multiplied with a phase factor. This is purely a phase factor because xk is same. Xn is xk, this is having xk. Only this phase factor is multiplied. What is the phase? E to the power j2 pi km by n. This m coming from this shift. Right? This m is coming from the shift. So therefore, the DFT, whatever is the DFT of xn, this is multiplied by a phase factor e to the power minus j2 pi km by n when the signal is circularly shifted by m unit. Clear? Very good. If you understood this, I hope you have understood this, then we are going to a very important concept that is called circular convolution. Circular convolution. Right. See, if you remember the linear convolution, generally we don't say linear convolution, we say convolution. If I say only convolution, we understand linear convolution. If it is circular convolution, then it should be mentioned that circular convolution. Now, see, suppose it is x1 of n star x2 of n. x1 of n star x2 of n. This is your linear convolution. I have written LC. LC means linear convolution.
Linear convolution.
That is x1 of k, x2 of n minus k. x2 of n minus k, this is a linear shift because mod n is not there. Now, if I want to have a circular convolution of these two, then we will put a cross, then we will make a circle. Here we will write a star. Linear convolution, we write a star. For circular convolution, we make a cross and it circle it. So within a circle, there is a cross. This implies, or this is the sign of circular convolution. Agreed? Now for circular convolution of this, here it is minus m divided by x1 of k, x2 of n minus k. Here it is x1 of m, x2 of n minus m. This is same, but this is a circular shift. I will write n, and this is I will write m equal to 0 to n minus 1. Agreed? So if we look at the equation, by looking at the equation, linear shift and circular shift, they are almost identical. Only difference is there k equal to minus infinity. Here m equal to 0 to n minus 1.
0 to n minus 1.
Otherwise, x1 of k, x2 n minus k, x1 of m, x2 n minus m. This is k, this is k, this is m, this is m, same. This is n, this is minus, this is n, this is minus. Everything is same. Only this is a circular shift and this is a linear shift. So this is the difference between circular shift and linear shift by equation. Agreed? Now, what you have to prove that if I take the DFT of this, then this will be x1 of k, x2 of k. What I mean? That is circular convolution in the time domain. This is nothing but multiplication in discrete frequency domain.
So linear convolution in motoi.
Linear convolution motoi. In linear convolution, what I have seen, time domain convolution, frequency domain multiplication, z domain multiplication, everything we have seen. Now, this is also same thing. What is that? x1 of n having DFT x1 of k, x2 n having a DFT x2 of k, then convolution of these two will be x1 of k, x2 of k, product of these two. Clear? Acha, one more. Acha, okay, later I will tell later. Let us see. Now, DFT of x1 of star circular convolution x2 of n. Okay. So, what is x1 of n? This convolution. This convolution is nothing but this equation. M equal to 0 to n minus 1, x1 of n, x2 of n minus n. So what I am writing, first I am writing this convolution within the bracket. Then I am finding DFT n equal to 0 to n minus 1 e power j 2 pi kn by n. Do you agree with that? Do you agree with that? Very good. Now tell me. Come here. What I am doing, I am writing m equal to 0 to n minus 1 here. M equal to 0 to n minus 1 here. I am writing x1 m here. Then n equal to 0 to n minus 1 here. x2 of n minus m n, x2 of n minus m here, e power minus j 2 pi kn by m. This term I have written here. This summation, this and this. Agreed?
Hmm.
Agreed? Now
Hmm.
you come here. This is equal to what? Just now I have proved. We have just now proved now. This is n equal to 0 to n minus 1 x of n minus m e to the power j 2 pi kn by n. এটা বার করেছি তো আমরা। This we have bound, right? So this equal to ultimately what we have got? Ultimately what we have got finally x of k into the power minus j 2 pi mk by n. Now if you look at this equation, this is nothing but Fourier DFT of a circularly shifted signal x2 DFT of a circular signal. So this is equal to x2 of k e power j 2 pi k this m by n. So this equation I have derived already. Only there was x, it is x2. So I will write x2 of k e power j 2 pi k m by n. Agreed? Agreed?
Yes, sir.
Fine. Now what I am writing, x2 of k I have taken here. I am taking here. Then I am writing m equal to 0 to n minus 1 x1 of m e power j 2 pi k m by n. What is this? This is DFT of x1 of m.
x1 of k.
Okay.
So this is x1 of k, x2 of k. I hope this is all right. This proof is over. Okay. So this is also proved using circular shift property. So what I have discussed, first concept of circular shift, then I have distinguished modulo and operation with respect to negative value and positive value. Two things I have done. Then I have tried to prove the property of circular shape. Then I am using that property. I have proved the circular convolution. If you have any doubt, if you have? No doubts.
No, sir.
Very good. So then it is very good. Then you are understanding well because this is a new topic, na?
As
This topic is a new topic. Since you have no doubt, means you are doing well. Is not it? Huh? Huh?
স্যার বলছিলাম সেকেন্ড লাইনটা একটু বলে দিন না এখানে
সেকেন্ড লাইনটা বলো তো এইটা
এই যে সেকেন্ড লাইনটা
এইটা যেটা
হ্যাঁ এটাই
আচ্ছা x1 কনভলিউশন x2 এটা মানে কি দেখো x1 কনভলিউশন x2 মানে হচ্ছে এইটা x1 অফ k x2 অফ n k এই যে x1 x1 সার্কুলার এইটা x1 সার্কুলার কনভলিউশন x2 অফ n তার মানে হচ্ছে এই জিনিসটা রাইট এই জিনিসটা আমি ওখানে নিয়ে বসিয়েছি what I have done that this is convolution. So circular convolution means this particular portion. This is okay. And if you want to find the DFT of this will be n equal to 0 to n minus 1 e power j 2 pi kn by n. Agreed? Because I am trying to find DFT of this thing. So this thing equal to what? x1 of m, x2 of n minus n m. This is corresponding to this thing. Now DFT means n equal to 0 to n minus 1 e power j 2 pi kn by n. Agreed? Is it okay? Huh? I hope it is all right. Now if you ask me what is this line n equal to 0 to n minus 1 x2 this we have derived. This is nothing but a circular shift of x2 of n by m unit with respect to modulo n. Is not it? This we have derived. What is that? x2 of power minus j 2 pi mk by n. Agreed? Well,
yes sir.
so using this we can prove this property. Okay. Now what important thing I want to mention here, circular shift this property I didn't find a book where it is correctly written. So you have to only follow this note because in books this derivation is incomplete. Whatever derivation is there in the book, if you write in the exam, you won't get marks because this derivation I have seen in most of the book is incomplete. And
বই নেই
বই নেই
না স্যার
হ্যাঁ স্যার বই তো নিয়েই আসেনি বাড়ি।
কিন্তু
এখানে আছে দুর্গাপুরে।
কিন্তু বই ছাড়া বুঝতে পারছো তো?
হ্যাঁ
হ্যাঁ
স্যার
স্যার।
বুঝতে পারছি।
আচ্ছা, তারপরে সার্কুলার, আচ্ছা আমার টাইম শেষে 6 মিনিট আছে আর। আচ্ছা, ঠিক আছে, অসুবিধা নেই। ওকে, নাও
স্যার একটা কোয়েশ্চেন
বলো।
বলছি লিনিয়ার শিফটে মাইনাস ইনফিনিটি টু ইনফিনিটি কনভলিউশনটা হচ্ছে এখানে 0 to n-1।
কারণ হচ্ছে কি, the endpoint DFT is defined on the basis of point. On the basis of point means I cannot say simple DFT. If I say DFT, then I have to specify point. It is defined on endpoint. Fourier transform is not defined on endpoints. And moreover, Fourier transform in linear convolution and all these things, you are having Fourier transforms and Z transform. So they are not defined on number of points. In DFT, which corresponds to circular convolution, they are defined on number of points. If I talk of a DFT of xn means we have to specify how many points. It is the n number of points. So DFT always defined on the basis of n number of points, which is not so in case of linear system. Here, okay?
Yes.
Acha. Next we are having around 5 minutes. 5 minutes I want to see one or two Z transform problem. Then first you will see this problem, right? Log of 1 plus z inverse. Okay.
কোন
হ্যাঁ স্যার।
So this problem could be solved in 2 ways. Okay. So let me explain first of all. Now first what I am doing, I am getting the expansion of this log of 1 plus x. Log of 1 plus x is x minus x square by 2 plus x by 3 minus x4 by 4. See, when it is log of 1 plus x, then it will be alternate positive negative, and when it is log of 1 minus x,
All
then
positive.
all negative.
All negative.
All negative. Log of 1 minus x means these are all negative. Okay. Now if you look at this term, by looking at the term, what you can understand, this is corresponds to n equal to 1. Agreed? This corresponds to n equal to 2. This corresponds to n equal to 3. Then I can write directly xn equal to 0, a minus s square by 2, a cube by 3, dot dot dot. Okay. So if you write this is the solution, you will get full marks, not an issue. Not an issue. Now, but in suppose say if you look at gate examination, first of all, this okay?
Yes sir.
Achha. Now for gate examination, other parts that much big solution may not be there. Then we require a compact form. Now how to get this compact form? By looking at this. Okay. Now this is corresponds to n equal to 1. Agreed? This is corresponds to n equal to 2.
2
Now if I say this first term corresponds to n equal to 1, what is the corresponding, what is the corresponding step function? U of n minus 1. Agreed? Suppose if a time domain signal, listen carefully, if a time domain signal starts from n equal to 1, what I can write? U of n minus 1.
Yes.
Everybody agrees with that?
Yes, sir.
If a time domain signal starting from 0, I write un. If a time domain signal starting from n equal to 1 to infinity, I will write n equal to minus 1. So first term is u of n minus 1. Understood? Next term is, first term it is 1, second term 2, third term 3, time is also 3, time is 2. So I have to divide by n. Agreed? Next, see, in first term, this is a, first term a, next term a into, it should be minus a to the power 1 because this is minus a square. Next term is a to the power minus a square, so it will be plus a cube, right? So therefore I will first write a because this term a is there. Then while choosing the next term, I will write minus a to the power n minus 1. Suppose n equal to 1, this 1 minus 1 equal to 0, so a to the minus a to the power 0 means 1, first term will be matching. Now if I write n equal to 2, 2 minus 1 is 1, so minus a, this is minus a square, but the rest of the term will matching, so this will be the solution. So in GATE examination, what you do, first you solve this one quickly, writing the series very quickly, add 4 option will be there, so you do that one in u of n minus 1. If 4 answer, one answer u of n minus 1 is not there, that was cancelled. By that way you can match this. So today I am having less than 1 minute, so second method of solution I will explain tomorrow. Okay,
ডেরিভেটিভ করেও তো একটা করা যাবে, দেখুন এদিকটা যদি ddx of x of 0,
হ্যাঁ সেটা করেছি আমি, সেটা কালকে দেখাবো। দিস ইজ দ্য সিম্পল ওয়ে টু